Hi, welcome back to the channel. I'm Neil Millard, the DevOps expert, here to answer any of your IT questions. If you're in IT, have a question, come ask me a question. Straightforward enough. Somewhere in the comments there'll be a link to a form maybe, or hey, add a question into the comments and I'll come back to you. With that said, let's talk about today's subject, which is DevOps in software engineering. What the heck does that mean? Well, let's crack on with it. Today, I'm going to talk about several steps about how DevOps is affected, helpful, or otherwise related to software engineering. So the role of DevOps in software engineering, moving on swiftly to understanding the historical divide between development and operations, promoting a you build it, you run it, implementing cross-functional teams, and techniques for improving collaboration and empathy, which is kind of at the core of what DevOps is about. The role of DevOps in software engineering, we need to have a little history lesson. Skip to the next section if you know what DevOps is already. So the goal of DevOps was to reduce context switching and handoffs. You know, you've had an issue before where you're ringing up somebody and they'll say, oh, hang on, that's the wrong department. I need to hand you over to somebody else, which is fine. But the 2 minutes you just spent describing your problem to that person, you've now got to repeat that to the next person. There's no handoff information in between the two parties, and this wastes a lot of time. And the biggest handoff in software development is where the software's finished developing their code, hooray, and they want to get it into production. But production is guarded by these sysops engineers who don't want anyone touching their precious servers. A bit odd really, because without software running on the servers, there'd be no point for the servers. So the initial and most obvious goal of DevOps is to get the developers talking to the sysops people. Hence the term DevOps. If we can get these two teams working together, there's going to be less handoff. You know, the developers know exactly how the app works. The server operators know exactly how the servers work. And often, or rather before, there was little understanding of either party to either party. So let's collaborate, let's work together. Let's have the software engineers understand about servers. Let's have the server engineers understand about software. Crazy thought. Anyway, that was well over 10 years ago, I think now. And you can read more about that in a most excellent book that Patrick Dubois and somebody else wrote. The Phoenix Project. It's a bit of a story, but if you like stories, it's awesome. So with that out of the way, how do DevOps practices actually improve stuff? Well, they enable the information to be shared between the two parties. Let me give you an example. I was at a customer site and the developers were developing a .NET application. I know. And this .NET application needed to run on two servers because they wanted some, reliability. If one server goes down, let's have another server just in case, or even spread the load between the two. Amazing. But they wrote the application in such a way that every time a customer logged into a server, they would ask them to log in again. That's no big deal, I hear you say. Well, if you're logged onto your server, tappy tap halfway through the application process, and then the server goes down, or for some other reason the traffic can't get through to that server. It's too busy serving other requests or something like that. So your traffic gets routed to the other server because it's less busy. Great. And the trouble is, it asks you to log in again. And then once it's asked you to log in again, you have to start the whole process again. That's not a very good experience, and developers couldn't understand why this was happening. So, with my sysops and DevOps hat on, I went down to their office in person, this was before Rona, and sat with them and went through the steps to understand what the problem was. It turns out the fix was pretty easy. What they were doing is they were using a local database for each server, and that was okay for the cached information. Then they had another database that was shared, and so all the session data would be shared in this database. Great. What's the problem, I hear you ask? Well, the problem is that the data was encrypted. Okay, that's fine. The real problem was that each server, we've got 2 servers, remember, was using a different encryption key. This meant that if you jumped over to the other server, it could see that you had session data and it was all there and couldn't do a damn thing about it because it was encrypted. So where did this issue appear? I don't really know. So I said, hey guys, use the same encryption key across both servers. And like, Neil, you're amazing. I know. And so they did this. We did another deployment into pre-prod. Sure enough, pre-prod was working well and it shared information. Rolled it out to prod, and the customer's experience is instantly 100% better. So this is where we can talk to each other, understand things, because it meant I needed to understand how the application worked, and they needed to understand how servers work, and working together we came up with a solution. Fabulous. But there was a historical divide between development operations. As I mentioned just now, operations are very protective over their servers. It's networks, it's cables, it's physical boxes. It's all very complicated, and how could a developer possibly understand any of that? Likewise, the developer mindset was very much code. It involves libraries and source code and things, and it's very complicated. Why would a server person ever know anything about that? I've also heard some of my software developer friends, yes, I have some, and they say, oh, DevOps is so boring. Of course, they're using DevOps in the SysOps point of view. A lot of people refer to DevOps engineers as cloud engineers, as SRE, which ultimately is SysOps engineers. It's system engineers who understand servers, who happen to store their configuration, infrastructure as code, if you like, in source code. That's not really DevOps, but we digress. There was a mindset, there was priorities, there was goals. The goals for the sysadmins is to keep the server running with as little downtime as possible. And that's fine until a developer comes along with a new version of their code that they've not tested properly. They load it onto the server. The SysOps guys are trying to go through the README. It's not installing well. There's miffed off configuration, and then 2 hours later they've done a massive rollback. All this on a weekend, because that's when the servers are least used by the customers. These are very poor feeling, both for the SysOps guys, because they tried to do a deploy and they were completely stuffed by the developers, and the developers don't feel happy about it because they had their lovely code and the stupid SysOps guys couldn't even install it. This went on for years and years, just throwing code over the wall. Okay, the documentation got a little bit better perhaps, but no one thought to put these two in the same room together. And so from this siloed approach, that's where we got this mistrust between the two parties. So one answer to this is you build it, you run it. This is where the developers and the SysOps people have shared responsibility for both developing and running the application. This includes the application health. Does it actually work on the server? The performance, does it work well on the server? Do the servers need upgrading, or does the code need rewriting? Each one of those parties can't decide that. It needs to be a joint decision. And so the developers, by working with the operational guys, got operational skills experience, understand how networking and how servers work and how that impacts how their code runs. Likewise, the operations engineers could contribute to the design process. Make sure that when you scale your application across more than one server, it's not doing daft things like just using one encryption key per server. It's actually got the same encryption key shared across the whole architecture, and therefore everything runs smoothly. Okay, so decided upon, you build it, you run it, And the easiest way to implement this is to have a cross-functional team. What the heck's that? Well, in order to break down the silos, let's have one team that contains several developers and several DevOps. Obviously, the smallest team you could get away with is a team of 2. I'm sure 2 people could easily demolish 2 pizzas. One developer, one sysops person, working together, pairing together. They both learn from the other and they both deploy together. So by having a cross-functional team, not only do you cross-contaminate all of the thoughts and knowledge between the 2, you also have a shared direction for them to face in. So we can reflect this in metrics. Have shared goals. We want application uptime, which depends on the developers and the sysadmin times. We can have other metrics that they can measure, like server errors or application errors, again, which are very closely linked. And if both parties are looking at these errors, they can work together to solve them. And through knowledge sharing and joint solving of problems, you can build that trust and build that relationship. Now, in a remote working world, is that easier or harder? I'm not sure. We've all got webcams now, like the one I'm talking to you now on. And so we can set up online meetings. Of course, it's much better to see somebody in 3D. So having on-site or in-person meetings is also good, particularly if it's not a work environment. A beer, anybody? Talking of beers, I'm sitting in Weston Supermare right now, and we have a tech meetup every month. You should come see us. It's called Weston Tech Meetup. Anyway, back to the meat. By facilitating regular meetups and feedback loops, then we can ensure that we're both on the same path, share ideas, even share criticisms after a while. After all, if the process is failing, then we should be able to talk to each other to resolve it. If you want to go radical, you can even swap roles. How well can the developer administer a server or an application when it's deployed in production? Or how about the sysops writing some code for the actual application? That might sound mad, but by swapping roles like that, especially if you're pairing, it doesn't really matter. Whoever's in control of the screen and the keyboard and the other one's observing and chirping in with their comments can actually foster a great understanding. And also, when you have better understanding, you can see the challenges that each other face. Of course, something goes wrong. Stuff always goes wrong. No matter how well you do it, stuff will fail. And so by having a trusted and a blameless post-mortem, by going through the events that unfolded, you can solve the problems together, building trust and getting to a working solution. And that's what I got for you today. We spoke about the role of DevOps in software engineering, understanding the historical divide, promoting a you build it, you run it mindset, implementing cross-functional stuff, and techniques for improving collaboration. If you've got any questions for me, then head over to devopsanswers.com and put them on the comments here. Stick them in the comments below. Ask me some questions. I love answering questions. I love helping professionals that are in IT, and we can work together and collaborate on something soon. But until then, may all your deployments go smooth.